All right, welcome to lesson 1.4. In lesson 1.4, what we're going to do is we're going to now add in the other types of polyhedrons or solid shapes that we can include on top of our rectangular prisms. So let's just do a quick review of the stuff that we should know for now. First off, we have our box, or our rectangular prism. Now, there's two types of formulas that we can encounter here. The most common one is one of these two right here. Either the surface area looks like this one or it's like this one. We have been using this one here. So if you're more comfortable using the one we were using before, go ahead and use that one because that's the one that I'm going to be using. This one here just pulls the two out of each one and just adds all the LW, LH, and WH together and then takes that and just doubles it as a group rather than individually. So I'm going to be using the one we've been using. So to find the area, I'm just going to take my formula and change it. 2 length widths plus 2 width heights plus 2 length heights. So put this information in. We know that our length was equal to 7, our width was equal to 3, and our height was equal to 3. So my surface area is going to be 2, 7 times 3, plus 2, 3 times 3, plus 2 times 7 times 3. And I'm simply just taking these values here and substituting them into the proper location on my formula. Taking your calculator, put it all in as one big long lineup, and do the calculation, and you'll find that the surface area for the box in question is 102 centimeters squared. There you go, a review of how we do a box. Now, last year we also did a cylinder. Now the cylinders have 3 dimensions that you have to really know. One is you have to know the diameter. So D is equal to, I guess I should make it a capital D like normal. The diameter is equal to 7. My height is equal to 5. And halfway across, this is my radius. And my radius is equal to 3.5. These are the 3 pieces of information you have to know, besides the fact that pi is equal to 3.14. Now we're going to use 3.14 because if you use a pi button, or so if you're at home and you don't have a pi button, then your calculations won't work, be the same as when we correct them. So if you use 3.14, everybody is the same, and you can use a cheap calculator to do this. You don't have to have an expensive one. So let's take a look at what we're going to do here. We've got our formula, and our formula is based up on this. This is pi r squared, that's a circle. And there are 2 circles on this cylinder, one on the top, one on the bottom. That's why that's multiplied by 2. If you ever have to do a pail, all you have to do is take this 2 out and only calculate the bottom of the pail. The other one is pi d, that's circumference, and then h, that will give you the label that goes around the outside of our cylinder, and that will be the walls of your cylinder. All right, so taking a look at our formula, we've got 2 pi r squared plus pi dh. The numbers that you put in, we know 2, obviously. Pi is 3.14. We got our radius up top. Our radius was equal to 3.5. Our diameter was equal to 7. And our height was equal to 5. I'm just going to jot those things down so I don't mess them up. So r is 3.5. And we have to square that. And then I have 3.14. That's my pi again. My diameter is 7. And my height is 5. Sticking all that in your calculator, your surface area is going to be equal to 186.92 centimeters squared. So there's a review of how to do a cylinder. Okay, the next one is a right triangular prism. And this is what this looks like. And again, there's a lot of information on this, and this is where a lot of people mess up. All right, so keep it straight. I'm going to put my information down here on the bottom so I can keep it. I have my h, which is equal to 6. I have my base, which is equal to 9. I have my width, which is equal to 5. And I have my ramp, which is equal to 11. A ramp is being like you do on a skateboard, going off it. This is the formula. Surface area is base times height plus base times width plus height times width plus width times ramp. So then just substitute the numbers in. Be very careful you don't mess it up. So B is 9, H is 6, plus B is 9, W is 5, plus H is 6, and W is 5, And finally, W is 5, and R is 11. Stick all those numbers in your calculator, one shot, and you should be able to come out with 184 centimeters squared. And that's how you find the area of a right triangular prism. Now, there's some things in here we have to take a look at to make sure you understand. This was possible because I have a right triangle here. I was given the hypotenuse, I was given the base, and I was given the height. All right? To find the area of a triangle, you always need the height and the base. You can't do it without it. And a lot of times what will happen is you will not be given one of those, or what will happen is they won't give you the hypotenuse. Now notice the hypotenuse is the ramp length. So if that's the case, you don't get this, but you're given the base and the height, you're going to have to use Pythagoras' theorem to find your hypotenuse. And that will be your ramp. And then once you have that, you can put it into your calculation. Let's take a look at a question which is very similar to that. This is not a right triangular prism. This is really got a 7 by 7. This is 7 and this is 7. So you know that if the lengths are the same on a triangle, that makes it a isosceles triangle. We also know the base, which is 10. So here's my base is equal to 10. I know my width is equal to 3. I know my ramp is equal to 7. But I have a problem. My problem is this. I don't know what the height is. It's not there. All right? I don't have a height. So I've got to calculate the height. Now, fortunately, in our little tool chest of mathematical abilities, we do know about Pythagoras' theorem. So what I'm going to do is I pulled that triangle off of my figure. And this right here is a right triangle. I know that this is 7, so my hypotenuse is equal to 7. I do know what this is on the bottom. Since this is an isosceles triangle, and these two are the same, that means that the base here and the base there are the same, both being equal to 5. So since I have a base, I have a hypotenuse, or I guess I have a b and a hypotenuse, I need to find that value right there to get my height. So this is a leg I'm calculating. So my calculation for leg is c squared minus b squared. So that means all I have to do is stick in my numbers. So I've got 7 squared, take away 5 squared. 7 squared is 7 times 7, that's 49. 5 squared is 5 times 5, that's 25. And when you take 49 and you subtract 25 from it, you end up with 24. And the square root of 24 is approximately 4.90 centimeters. Now that I know this height is equal to 4.90, I now have the information I need to calculate all of the different pieces. So I'm going to go on here. And I guess I did the calculation for Pythagoras' theorem on the previous page. So don't worry about it. You can just put this information from the previous page in here. So what do I need to do? Well, I need to find the two triangles. And if you remember my shape, it looked like this, right? I now know that my height is equal to 4.9. And my base is equal to 10. So I can find the area of the triangle. The area of a triangle being base times height divided by 2. So base is 10 and 4.9 all divided by 2. So if you take and do that calculation, that is 490 divided by 2. I've got my calculator here. So that's not 49, sorry, divided by 2. That means that this one is 24.5. Now remember, we have two triangles here. All right, so we have one in the front and we have one in the back. So multiplying that gives you 49 and takes us back to what 10 times 4.9 is. Yes, you have to do it. Now the bottom, we have to go back and take a look at what we had here. The bottom is a rectangle, and you'll notice that the bottom rectangle looks like that, kind of, all right? And it is 10 by 3. So moving forward on this one, 10 by 3, area is length times width, so that's 10 by 3, which means my bottom is equal to 30. All right, going back and looking at the ramps. Now you notice an isosceles triangle, so my ramp here is 7 by 3, and this ramp here is also going to be 7 by 3. So we really could do this in one step and double it, but let's do it separately. So this is 7 times 3. So that means that the one ramp on the left is 21, and the one on the right is the same thing. 7 times 3, so the one on the right is also 21. So now that I have all the pieces together, I can put them into my sort of a big, huge final add up. I've got 49, 30, 21, and 21. And if you add all that up, 49 and 30 is 79, 89, 99, 121. So there is my total surface area for this right rectangular prism, 121 centimeters squared. Okay, so I'm just going to pause this for a second, and I'm going to fix my notes because my notes are a little bit out here. Okay, I got things all caught up on my stuff here. Let's go on to our next example here. Now that we've done the individual parts, it's time to start making the composite objects. Now the thing about these composite objects is they're the same way as we did before when we had our boxes stacked on each other. But instead of being one box stacked on each other, now we're going to have things like triangular prisms on top of boxes or vice versa, stuff like that. And you're going to have to take and calculate the individual surface area of each figure or each shape, and then find out what the surface area which is overlapped and subtract that. Now let's take a look at this one here. We've got a cylinder and we have a right rectangular prism, a box. And you'll notice that right here I have a circle. Now that circle is the overlap, and we'll get to that in a moment. So first off, let's do the right rectangular prism. And again, I'm going to change my formula back to what you're familiar with. 2 length widths plus 2 width heights plus 2 length heights. So surface area, let's take a look at what we have for dimensions. I've got 12, 6, and 3. So length is 12, width is 6, and height is 3. So 2 length widths. So this is 2 times 12 times 6 plus 2 times 6 times 3. I'm running into my other room over here. Plus 2 times 12 times 3. All right. So surface area, when you add all of the stuff up, is 252 centimeters squared. Now my alarm has just went off on my phone, so it's across the room, so I'm going to walk over there and I'm going to turn it off. Be right back. All right, so I'm back. Now we have to find the area of the cylinder. If you look up at the cylinder, the dimensions I'm going to need are the diameter is 5. That means my radius is 2.5, and my height is going to be 4. So let's put that information into my formula. I think I'm going to drop down to my surface area part down here so I have room. Surface area is 2 times 3.14 times r squared, which is 2.5, square that, plus 3.14 times d, which is 5, times h, which is 4. Kind of running out of room there, so I put some x's in. So now when you do the surface area of the whole cylinder altogether, you're going to get 102.10 centimeters squared, approximately. So our total surface area is going to be 252 plus 102.10. That means my surface area is 354.10. Now that is the cylinder and the box without the overlap. So now we have to go back and figure out what the overlap is. Well, the overlap is a circle, all right? And the circle has a diameter of 5. And you remember the formula for circle is pi r squared. So that means I need an r. So my r is going to be half my diameter. So the r I'm going to take with me to my formula is 2.5. So here we go. The area is equal to pi 3.14 times 2.5 squared. When I do that, I'm going to get a calculation which gives me 19.6345. Goes on, multiply that by 2, and you're going to get 39.27. So going back to my original, that was 354.10. Take away 39.27, and my final answer is 314.83. So the surface area of this composite object, composite meaning more than one piece, is 314.83. Okay, so that takes care of a box and a cylinder. The other thing that we can encounter most commonly is a box and a right triangular prism. Now, fortunately for this one, if you take a look, I'm given a ramp right here. I'm given a height right here. I'm given a width right here. I guess that's sorry, that's the width that's over here. Width is 7. I'm given a base of 4. So for the right triangular prism, it's going to be fairly straightforward. It's going to use that information. The box has got length, width, and height, 8, 16, and 3, so that takes care of that. So let's take a look at the two pieces of information. Again, I'm going to change this out and use the other formula. 2 length W's plus 2 WH's plus 2 length H's. So, doing the information, I'm going to go to my box first, and I'm going to go back up here. My length is equal to 16, my width is equal to 8, and my height is equal to 3. I've got all that information easily available, so I won't mess up. So 2 times length is 16. The width is 8 plus 2 times 8 times 3 plus 2 times 16 times 3. Do all the calculations, and that shoots out 400. Now let's go to the triangular prism. Again, information that I'm going to have, going back up so I don't have anything messed up here. I'm going to need that my base is 4. I'm going to have to know that my height is 5. I'm going to have to know that my ramp is 9. And I'm going to need to know that my width is 7. All right. So now that I've got all that information in place, I'll do my substitution. So this should be 4 times 5 plus 4 times 7 plus 5 times 7 plus 7 times 9. And if everything's done right, your surface area should kick out 146 centimeters squared. So there we have the box, and we have the triangular prism. So now we have to calculate the surface area of our overlap. Now going back up here, the bottom of the triangle is a rectangle which fits right there. And you'll notice that it's 7 right here by 4. So 7 by 4 is the rectangle size, and there's 2 of them, one on the bottom and one on the top. So this is 7 times 4, and that area gives me 28. Now remember, there's 2 of them, so you have to double it. So that's 56. So taking and adding things up, we have 400 plus the 146 for the triangular prism. Take away the 56 for our overlap, which is 490 centimeters squared. So that leaves us with only one left, but for myself, it's lunchtime. Okay, welcome back. I just got back from lunch. It was a great Subway. Our next project is going to be kind of complicated. If you take a look here, I've got 2 rectangular prisms, one which is 8 by 3 by 2, and one on the bottom which is 14 by 8 by 3. And in the middle we have a cylinder which has a diameter of 2 and a height of 7. So what we're going to have to do is find the area of each one. So what I've done is I've created again three parts that will allow us to calculate the surface area of each piece individually. Again, what I'm going to do is change the actual formula here so that we don't have to change what we've been doing. So 2 length W's, 2 W heights, plus 2 length heights. Okay, so taking a look at this, our surface area, we're going to be using a large rectangle. So take a look and pull up your, the length is equal to 14, the width is equal to 8, and the height is equal to 3. So just put the numbers in. 2 times 14 times 8 plus 2 times 8 times 3 plus 2 times 14 times 3. when you do the calculations of all of these together, you should get 356 centimeters squared. Okay, so now I want you to pause the recording, and I'd like you to do the small rectangular prism. All right, just going to grab this stuff right here, move it out of the way a little bit so it's not in the way of our calculations over here. And we'll go back to what we were doing before. 2 length widths plus 2 width heights plus 2 length heights. So again, looking at my smaller box, this time my length is equal to 8, my width is equal to 3, and my height is equal to 2. I'm now going to take them and I'm going to put in the numbers called substitution. 2 times 8 times 3 plus 2 times 3 times 2 plus 2 times 8 times 2. And your surface area, when you put all this in your calculation, should be 92 centimeters squared. So hopefully that's what you got. Okay, the last part is the cylinder. And if you take a look at your cylinder, we have a diameter, which is 2. That means our radius is equal to 1, which is half our diameter. And we have a height, which is equal to 7. So taking a look at our diagram, or sorry, our formula here, that gives us 2 times 3.14, radius of 1 squared, plus 3.14 times the diameter of 2 times the height of 7. So my surface area of my cylinder is going to be 50.24. Okay, so I've got all the pieces now. All I have to do now is take a look at finally maybe adding all these together, and then take a look at our surface area of our overlap. Okay, so here's my numbers. I've got 356, and then I've got 92, and I have 50.24. And if my numbers are correct here, I get 498.24. Right. Now, the overlap is going to be the circles. And if you remember, there's a circle at the top and there's a circle at the bottom. And each one of these circles has the box on top of it. So 2 of these circles are going to be eliminated on the top. And there's a big box on the bottom here. So 2 of those have to be eliminated there. The formula for the surface, or the formula for the area of a circle is pi r squared. And since it's a cylinder, these circles are exactly the same size. So I can actually multiply them by 4. So I got pi, now, sorry, I guess I should put the number in there, 3.14, and the radius is 1, and that's squared, so that means that my one circle has an area of 3.14. Now, there are 4 of them, so multiplying this by 4 means that I have 12.56, I think, is my area. So 12.56 is the 4 surface areas of the circles. So now take the total surface area, 498.24, and take away 12.56. So 498.24 and 12.56. We need to subtract that. So borrow, that's an 8. Borrow, that's a 6. 7 take away 2 is 5. So there you go, 485.68. Centimeters squared. Okay, so we've done all the pieces, we've done all the different types of variations, so hopefully you can get these assignments done, and then remember to prepare for the final exam, or sorry, the unit final, and we will see you in Chapter 2.